Yeah, thanks a lot. And welcome to our open panel about benchmarking and application readiness. As already mentioned, we heard 3 interesting talks about how benchmarking is done today and what possibilities there are. And now we want to discuss this with you, the community, because we also heard that this is an important point. So the open panel is a little bit in the way that we will start with a normal panel situation, and then of course you come into action, so please be prepared.
Yeah, before we dive into the detail, let's have a short recap where we are at quantum computing. So the technology is new and has evolved quite a lot in the past months, years, really. So we are really at a different stage even compared to a year before. Applications, the software stack is evolving, is developed, and we are looking already for real use cases. So the play time is kind of over. Now it needs to get serious so that we take care about really business relevant problems. So benchmarking now also has a different position. So where we, in the past events, we talked about benchmarking. Yes, is it too early or not too early? Now it becomes more relevant. So, but where we are today, also in benchmarking, like in the technology development, technologies, we have the different technologies where we still are in the exploration phase, what makes sense, what it will be valuable in the future, and technology. For quantum, the challenge is everything is new. So the hardware technology is new, the component development, the requirements to the components, everything is new. The software, the requirements to the software, to the application is new. The way of thinking and developing application is completely new, and also use cases needs to be thinking in a way that's not only good for technical nerds, but really for business application. So everything, the entire industry in quantum needs to build up. What does it mean for benchmarking? Yeah, we heard a lot of benchmarking mentioned in the talks these days, but where we are with the benchmarking? We need it for every part in the new quantum technology, and so when we look at the current picture, where we are with benchmarking, we have just collected a few things in benchmarking.
Yes, as you may see on the slide, please don't read the slide in detail, it would take too long. But as you can see, we can divide the benchmarking into the areas of hardware and technology benchmarks. Now, there are the well-known candidates like number of qubits, physically or logical. Then we have software stack and functional benchmarking, and also the application-oriented benchmarks. So there are 3 totally different parts of benchmarking you can do on the one hand. And on the other hand, of course, there are a lot of users and benchmarking providers with all their own interests coming into this field. And so it's a highly diverse landscape that we are facing off. And at the end, if you are a user and want to use a quantum computer and just want to see, okay, which hardware is the best or fits the best way for me, and you see this, then I think it's a really difficult thing. And so this is what we want to discuss in the next few minutes with you.
Yeah. So we want to focus on one question, more or less, so what is really necessary to create a benchmarking system that is beneficial for the users, for the industry, and so on. So we will ask our panelists, but we would like to ask also you to think about what does it mean for you. First we start with the question let's start with you, Michael. What do you think is necessary that we get a meaningful benchmarking system? Now we have this broad base already here, but how we come to something that helps really and not introduces more unnecessary complexity?
I mean, so the way we do it, yeah, I mean, this might not be the only way. It reflects a little bit the complexity of what we see here. Yeah, I mean, it's really, there's a lot of things going on if you really want to compare different types of solutions. For example, this numerical accuracy problem or this point can alone be something hugely complicated. And therefore, that's why we always start from something where we have very fundamental reasoning why we believe the quantum computer will be better at some point. So the step 0 is always say, okay, I have really clear-cut reasoning without doing anything, yeah, in terms of running anything anywhere. I have fundamental reasoning why I believe at some point at least the quantum computer will be better. And then you start to run things, and then of course, in practice, of course, it really makes another sense to also say, look, there is a real problem. Let's now really try to solve it classically and see if we are able to do that for real, like completely the actual real problem to solve it, and see what remains really left over from that. And then you start running, I mean, at the same time, of course, you also do quantum computing, but quantum computing, to really run this type of problem on the quantum computer, I would not necessarily immediately describe as benchmarking, but as kind of fundamentally sanity checks to see additional problems that crop up, details of the algorithms to understand them. And therefore, it's super valuable, and today also really easily possible, to run 5, 10 qubit benchmarks. And these benchmarks, as I said, are not really speed or quality, but just to really be sure that you understand all the details of your approach, and there are no hidden assumptions somewhere that you don't have under control. Yeah? So building the best classical solution, understanding fundamentally why the quantum computer is better, and running small prototypical things to make sure you really know how this is going to look on the quantum computer and have the approach under control.
So it sounds more like building the benchmarks bottom up from the real application.
Yeah.
Yeah.
And a question for you, maybe. What do you think, who should be involved into the benchmarking process to ensure that the quantum ecosystem is aligned within, but also with the industry partners?
Yeah, I think this is key, really, not just within quantum, but in the broader community, as you said, with industry and academia and beyond, because often I think a challenge is just a lack of clarity in the communication. So when you see some newspaper headlines then, and obviously there are all these terms like quantum advantage and supremacy and utility and value, and that alone you could create a slide looking at those, and people who are organizations who are not so much involved, of course it becomes very confusing then to distinguish between those. And so I think key is clarity around what are we actually trying to optimize. So for example, here in the middle, there's a range of different ones. Often a user may not even be so explicitly conscious of that. Am I trying to get a more accurate solution, or am I just trying to get it faster? And so then, again, if one is not so involved, it becomes very easy to perhaps also just dismiss quantum. Oh no, it's not better, but better in terms of what? And then, of course, it's also an ongoing update. So I think one thing which I do not actually see on here is energy efficiency. So that's an interesting one. We've also had some talks around sustainability and the like. And so that's, I think, one of the ones which has emerged over the last couple of years to think, okay, are there applications where I really care about the energy efficiency of carrying it out? So I think it's clarity in the communication, particularly with the broader ecosystem, involving those as well, because of course they do provide key input then in terms of the value that can be had, and then continually updating this as well.
Mm-hmm. Thanks. So, speaking of community.
Yeah, we have prepared a little Slido survey. We hope it works. We ask you to provide your input. Please scan the code, and we have one question. We want to better understand where the community is thinking about benchmarking. What are the contacts so far? So this is the question, that is, which benchmarks or methods have you worked with already or you consider important? I hope the results show up. So this is a bit a test. Good.
So, perfect. And you don't only need to be part of the discussion with Slido, you can also just raise your hand. We have someone with a microphone here, and then, of course, I'm asking your question directly to our speakers. But in the time we wait, Michael, I have a question about NMR spectroscopy. Looking at the slide we just had seen, there was a lot of technological benchmarks, but I haven't seen anyone on your slide. What do you think? Which benchmark can be interesting for you?
I mean, the benchmark comes from the fact if somebody has a molecule, can we calculate the spectrum? And we have a very specific type of also technical benchmark where we show that our methods converge. So to say that you can make a so-called convergence benchmark that just show that you have basically solved it to the accuracy that is fundamentally possible. So we do have very distinct benchmark work on this topic, but it's just using the best classical solver or the best classical quantum computing equivalent and seeing does it fully converge. Yeah, I mean, this convergence is a very technical aspect of how this is done. So we have our own method to fully benchmark. Of course, you know, there are still a lot of questions open on the quantum computing side as well, where it would be nice to have, I mean, we're looking forward to see quantum computers improve ever further, to have more possibilities to use them.
But if you have to guess, anything like number of logical qubits or
I mean,
circuit dips or something like that?
Yeah, so I mean, we hope it's still possible to do with NISQ, so-called noisy qubits. It's very difficult, but it's very, I mean, the problem maps very closely, and I think if qubits will have two qubit gate fidelities above 99.9%, maybe it's possible. Let's see.
Cross the fingers.
Yeah, cross the fingers.
So a question to Florian from my side. What feedback do you get when you work with users? Do they have requirements? What requirements they come from at this still quite early stage in the technology?
It really depends on the type of user. So this comes back to my earlier comment. If you have people who have been in quantum science, they know exactly what they want and they are aware of the landscape and they say, I want this fidelity or this system or this approach, right? But I would say that is still by far the minority. Most often you will have people who say, I really don't care and I also don't want to know about those aspects, and it's just what works for the system. And then I think it's the job of this sort of ecosystem, people who are in the field, to then help guide that along. And that, of course, it's not a black and white, because I think there's a lot of work that still needs to happen right now in terms of which application lends itself to which kind of systems, how do you then measure that, what sort of perhaps toy problems, proxy problems do you use, which you know can scale to the more interesting ones. So I would say, I think in some cases it's very clear what is needed, but in most cases, users don't really want to get involved into the weeds, as interesting as we might think it is, but they don't want to know.
Thanks. If I look on our Slido, then I see a quantum volume. And regarding quantum volume, my question is, how do you think about benchmarking values which came from specific companies? Do you think these are useful too, or maybe a little bit problematic?
This is a fine quantity. It's good. I mean, I just normally look rather at raw numbers like 2-qubit gate fidelity, but quantum volume puts fidelity and conductivity together, which is reasonable. It's a good benchmark number, reasonable number. Can I just ask, does anybody know what quark means? I mean, it's very big. Seemingly several people have chosen it.
No.
I see.
It's a benchmarking.
Okay, thanks. I was shortly outside, I'm sorry.
That brings me to another question. So now we have different approaches for benchmarking. Now different players come with something that matters most for themselves in applying. But what do we need in order to have a kind of standard? So who we could bring together, what is necessary from your perspective to get from these individual solutions, the fractionalization of benchmarking back into something that is helpful for a broader range of providers but also end users, maybe in the software area or so, wherever.
Okay, so on a very practical level, our experience is that if you use an actual quantum computer, they have a generally characterized performance by quantum volume, for example, or by fidelities, but also can differ quite a lot from day to day, which is the reason for this is that normally they are somewhat difficult to stabilize and difficult to not benchmark, sorry. The quantum computer isn't benchmarked, the quantum computer is characterized and, how do I say, tuned up, let's say, yeah? And what we would love if the providers would be more able to keep a little bit more stability, and then that these numbers that they give are really the ones that I use at this given moment if I run an algorithm. That would make it a little bit easier to judge kind of the relationship between a result and these numbers and what I would expect, what I need in terms of quantum volume and so on to go forward. Because as many people who have run actual things on quantum computer might know, your fidelity or your quantum volume at a given run might be something on paper, but might differ a little during the actual run. And if this stability could be increased, I think we could make more sound judgment what we really need.
So it's a kind of internal, sozusagen in the quantum technology world, we need to understand what is the base in order to really make the higher level, in the upper stage benchmarking trustable, because it relies on the base.
I mean, these quantum volume numbers are always very good in terms of, there was an experiment that showed this quantum volume is fundamentally achievable. That's excellent, yeah, and that's good to know. But then when you run real practical things, you want to know that you really run it at a certain state of the quantum computer. And then you can judge your result and from this gain more and more feeling about how things perform.
Yeah.
I think there are also different ways this can evolve. So it could be that there are some benchmark which becomes so useful that, well, everyone is just using it. So maybe a more organic kind of growth. Or if we look at some of the other quantum technologies, like in the security space, you've had the NIST standardization. So maybe there's also something more at the international level. So I think it could come from both of these avenues.
I want to point out, in terms of exactly getting involved, I think it seems to me very reasonable if we have more really good and well-maintained classical benchmark databases where people really made an effort to say, this was the problem. Here it is really nicely specified that you can take it. This is a really super high-end classical solution time we had for it. And this is maybe a scaling at the problem becomes larger. Making this type of database is extremely time expensive. That's why they don't actually exist to a large extent for optimization. Despite it being a topic since 15 years or even longer, to be honest, I would say the only really good database that I have seen has been published basically half a year ago or so, I would say, or a year ago. Some people might know the work. Yeah? And so more of this type of databases would be really helpful. And actually, this is also why we, for this NMR problem, we are going to publish very nicely specified problems and give people access to our classical solver to have a feeling how this would look on a normal computer, to have more standardized benchmarks.
I'm very sorry, but we're running out of time. Yes. I'm afraid. So I think summarizing, there is no easy answer. And if you want to use a benchmark, then you have to go into the topic. I'm very sorry. But maybe as a last question, and maybe as just a very short answer, if a user is starting to work with quantum computers and is searching for the best benchmarks for his or her use cases, what would be your recommendation?
Okay, if it's, okay, I can recommend our own benchmarks for the specific problems that we work on. I think they're going to be really good. But beyond that, there are good benchmarks now on quantum, on optimization, of course.
My suggestion would be what I said earlier, think about what you're actually trying to solve and optimize, because you can say, okay, I want to achieve the best possible performance compared against a lot of the state-of-the-art algorithms, but more realistically, often in data science, you say, well, I just want to make it better. And so this is a very different approach, and I think you have to have clarity for yourself in that space first.
Thanks.
Okay, now we're already at the end of our small discussion round, but if you are interested or if you see the need to contribute to benchmarking, please get engaged. Yeah? So at the early stage, we still can define what benchmarks are relevant. We can shape in which direction it goes. At Bitkom in the working group, we also monitor this. If you are interested, engage in our group, and we want to bring this topic further. So thank you for your attention.
Thanks. Thank you.